Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello friends, a very good afternoon to all of you. So guys, today we have a very interesting topic with us. Very short but very interesting topic with us. In fact, I would try my level best that for this particular topic, you need not refer any book. This topic is actually very short in our exam. Matlab it's very small and frankly speaking, chances of getting a question on this topic are very less because it's a kind of assumption. Okay? So we will try our level best that the topic is completed within maybe 40-45 minutes. And then 40-45 minutes we will spend some time on numericals from last class also. Okay? So I think, I hope you remember what we have been doing till now. So we have been discussing about the Eulerian approach. है ना? So we have seen what is Lagrangian approach, what is Eulerian approach, what is the difference between two approaches. We are going to follow Eulerian approach. In Eulerian approach, every property is written as function of position and time. है ना? Property is written as function of position and time. So what you say? The value of property. है ना? What this means? What is the meaning of this? The value of property P at point, which point x comma y comma z, at point x comma y comma z when the time is t, when time is t, है ना? So what is the value of pressure at the inlet of the turbine in the morning? So this is Eulerian approach. This is what Eulerian approach is. Okay? So I think this is what we were discussing, है ना? And when time is t, when time is t. So I think you can write like this. In your notes, you can write like this. And for the आज ना ICICI वाले बहुत फोन कर रहे हैं. उनको भी पता है कि साला इनके पास पैसे नहीं है, तो इनको कॉल करो और लोन के लिए पूछो. हाँ सुबह से यार 10 बार कॉल कर चुके हैं, पता नहीं यार क्या चक्कर है इन लोगों का. ये अच्छा है कि ट्रू कॉलर tells you the name, already tells you the name. So that is the good thing. Now for the others, but I saw your message yesterday. Actually, from 2-3 days ना, I was a little busy with some seminars. तो क्या होता है कि मेरे को नहीं पता कि कभी आप लोगों के साथ सेमिनार किया है या नहीं. तो कभी कभी क्या होता है कि डिफरेंट जो कॉलेजेस होते हैं, तो उन कॉलेजेस में सेमिनार्स चलते हैं. तो 2-3 दिन से बिजी चल रहा था, इसलिए रिप्लाई नहीं कर पा रहा था. और फिर कुछ पुराने स्टूडेंट्स के टेक्निकल डाउट्स भी पेंडिंग थे, तो वो भी देख रहा था. ठीक है, तो आज बात करेंगे. ठीक है, आज बात करेंगे. आई नो योर क्वेरी. इनफैक्ट यू नो वार्षने सर कॉल्ड मी स्पेशली बिकॉज ऑफ योर क्वेरी. तो मैंने कहा कि ठीक है, आज मैं बात करूंगा, बट पहले थोड़ा पढ़ लेते हैं. सो वैल्यू ऑफ प्रॉपर्टी एट पॉइंट एक्स कॉमा वाई कॉमा जेड व्हेन द टाइम इज टी. सो व्हाट वी लर्न, when we will take the derivative of this property, we will find out dp by d time, है ना? So now property is a function of 4 variables. So when you will find out dp by d time, you will get del p by del time plus u del p by del x plus v del p by del y plus w del p by del z, है ना? So who will tell me what are the meanings of these 3 boxes? इन 3 boxes का क्या मीनिंग है? कौन बताएगा इन 3 boxes का क्या मीनिंग है? अदर्स या जो लोग भी वीडियो देख रहे हैं. So I think 7 people are watching the video. मैं हमेशा बोलता हूँ कि यार आप में से एक मैं हूं, पर बाकी लोग तो कमेंट करो. तो कौन बताएगा इन boxes का मीनिंग क्या है? What is the meaning of these boxes? So what is the meaning of right hand side box? What is the meaning of right hand side box? I think right hand side box, that is the convective difference. Please note, this is called as convective difference, and it is a term of Eulerian approach. Convective difference is at a particular instant of time, exactly in the morning, 7 o'clock, exactly at 7 o'clock, what is the difference of pressure between inlet and outlet of turbine? ठीक है ना? So at a particular time instant, difference of property between 2 points. So this is convective difference and it is a term of Eulerian approach. Then I think the middle box, that is called as local acceleration, local change, है ना? So this is convective difference between 2 points, and this is local change. Change means how the value of property at a point will change with the time, है ना? So how the pressure at inlet of turbine is changing with the time. So here we are talking of particular location, and this dP by dt, this is actually a term of Lagrangian approach. This dP by dt tells us that the particle which is crossing the point xyz at time t. So how the property of the particle is changing with the time. ठीक है ना? तो हमें ध्यान रखना है कि dP by dt जो है ये लैग्रेंजियन अप्रोच का टर्म चला जाता है, ये पार्टिकल का रेट ऑफ चेंज बताता है, ये आपको बताता है लोकल चेंज. सो वी सॉ देयर वाज अ थर्मामीटर, द थर्मामीटर वाज मूविंग अलोंग द फ्लो, सो थर्मामीटर वाज मेजरिंग द चेंज फॉर अ पार्टिकल. सो थर्मामीटर वाज गिविंग अस dP by dt, but thermometer was located at a particular position, thermometer was stationary, so it was talking of a point, so it was giving us local change, है ना? So I hope these things you remember, these things we have already done. Now the next thing that we have to do is, we are writing property at a point. We are writing property at a point. So question is, what is a point? This is what question is. What is a point? When you are describing property for a point, what is a point? Okay? So this is the question that we are going to solve. And the answer to this question, it comes from concept of continuum. Okay? What it is going to tell you in layman language, what does concept of continuum tells you? Concept of continuum gives you the description of point. It will tell you point. ठीक है ना? तो आओ देखते हैं concept of continuum क्या है. So firstly, we will frame the understanding of this concept in rough. ठीक है? So first 25-30 minutes you can say we will do rough work only. So in whatever is going on in the slides, you can note down directly. And once you note it down, then you can write the fair definition. Hi Satyam, क्या हाल है? सत्यम, मैंने पता है क्या सोचा था कि to you guys also I will share it, because वो जो अभिलाष क्वेश्चन पूछ रहा है ना बार बार, तो अभिलाष वाला क्वेश्चन यहाँ सॉल्व करा के मैं आप लोगों के साथ शेयर कर दूंगा. But I didn't share it earlier because I also know कि you guys are busy right now, है ना? So giving you too many links, it would just be a spamming. But definitely, if you have a lack of understanding of this topic, अगर यहाँ पे थोड़ा सा भी weak लग रहा है कुछ, या revise करना है, तो you can watch it. ठीक है? Okay, so this is what we want to do. We want to define the point. We want to define the size of a point. So you can write in rough. This is not the actual definition, but a layman definition. Concept of continuum defines a point. It will define a point. Okay. Now, first of all, please understand that when you say point in a 3D space, so room is a 3D space, है ना? So when I will say this point will actually be a volume. But if I say point on an area, so 2D space, so when I say point on a surface, then it becomes area. ठीक है? So we have to understand, and I think this we can easily imagine, that if we are talking of a 3D space, we are talking of a volume, then the point inside the 3D space, that will be a volume only. That will be a 3D body. So I will say very small volume. A point means a very small volume. But if I have a surface, on the surface I take a point, then the point will be an area. So very small area. ठीक है? Now question is, what is the size of this area? What is the size of this volume? This is what we want to address. Okay. So first of all, how many of you know what is the size of an atom? Say for example, hydrogen molecule. Okay. Say for example, hydrogen molecule. So you guys can do one thing. यू कैन गूगल इट ऑल्सो. अगर नहीं पता तो गूगल कर सकते हो. हाय विनीत, क्या हाल है? बहुत दिनों बाद देखने को मिला. विनीत, क्या हो रहा है कि आई एम एग्जीक्यूटिंग अ फुल सीरीज ऑफ फ्लूइड मैकेनिक्स. तो अगर भगवान ने साथ दिया तो हम शायद ये पूरी सीरीज चला पाएंगे. ठीक है, पेट भरता रहा तो पूरी सीरीज चला पाएंगे. तो एफएम की पूरी सीरीज चल रही है ऑर्डर वाइज, और कोशिश यही है कि 5 महीने में जितना भी काम हो सके कराएं. तो ऑल्टरनेट डे बेसिस पे क्लासेस होती है. एंड पूजा क्रिएशंस ऑल्सो, अ वेरी गुड आफ्टरनून टू यू. So my question is, does anyone know what is the size of an atom? What is the size of a molecule? Say for example, hydrogen molecule. I am going to give the example of gas. That's why I said hydrogen molecule. Can anyone tell me what is the diameter of hydrogen molecule? No? अच्छा, देखो क्या होता है. Hydrogen atom. So radius of hydrogen atom is something around 50 picometer. So when you talk of hydrogen molecule, that is H2, right? So for H2, the radius of molecule is 120 picometer. Now question says, what is a picometer? So picometer means 120 into 10 raised to power minus 12 meter. And if I consider this 1.2 into 10 raised to power minus 10 meter. I think this is a common unit of meter, right? This is a common unit. We call it as Armstrong. How much? Armstrong. Okay. So this is the radius of hydrogen molecule. So you can say that molecules are of this order only. So a size of molecule will be 3 Armstrong, 4 Armstrong, 5 Armstrong, है ना? Depending upon the structure. So if you have a hydrocarbon, the size can reach up to 1 nanometer also. Okay? So this is the size of molecules. Now guys, what we have a room, say for example. So right now I'm talking of a 3D volume. I'm talking of what? 3D volume. And in the 3D volume, let me take a point, okay? And the point has some coordinates x, y, z. Okay? Obviously this point is going to be a volume, and when you will go for, if you will learn finite element method, FEM, or if you learn CFD, then you will learn that in our analysis, it is up to us what to give the shape of the point. Okay? It depends upon us. We are actually free to choose what should be the shape of this point. So say for example, this point is a spherical point. Okay? Let us suppose this is a spherical point. However, it is wrong. Okay? In CFD or FEM, we cannot take a spherical point. You have to take cuboidals or pyramids, matlab whose boundaries will match completely. Something like this. Why I'm saying like this? Because for a cuboidal point, the boundaries will match completely, right? But for spherical points, the boundaries will not match. है ना? So this is a wrong analogy. But for explanation, it is fine for now. Okay? This explanation, it is totally fine. Now what we have a point, and we also know that molecules of a gas are free to move and they are moving randomly. Now let me assume that this point, it has some diameter, and the diameter of this point, it is of the same order, Armstrong. Same order, maybe 5 or 6 Armstrong. Okay? But it is of the order of Armstrong. So how much is Armstrong? This is 1 meter. This much is 1 meter. If I take 1 by 100, that will become 1 centimeter. If I take 1 by 10 again, that will become 1 mm. So basically 1 by 1000 of 1 meter. Now for that 1 mm also, again take 1000, that will become micrometer. And then again take a 10,000, that will become Armstrong. So definitely it's very small. See again. So what we have a point whose order is 5 or 6 Armstrong. And since we are talking of hydrogen molecules, so you know what is the order of hydrogen molecule, है ना? So maybe within this point there are 10 hydrogen molecules. How many hydrogen molecules are there? 10 hydrogen molecules are there. Okay. Now we also know hydrogen molecules are moving in random directions. So what will happen? Obviously, since these molecules are moving in random directions, some molecules from inside, they will go outside, and some molecules from outside, they will come inside. So maybe initially 10 molecules are there, 3 molecules went outside and 2 molecules came inside. Okay? Now I hope you understand there are two terms over here. One is the molecule inside the volume, molecules inside the point. And the other term is molecule coming inside or going outside the point from the surface. है ना? What is 10? 10 is the number of molecules inside the point. And 2 or 3, that is the molecules going outside or coming inside. है ना? So there are two terms over here. Now check, there is a theater. So I think the number of audience in the theater, that will depend upon the volume of the theater, है ना? And how many people are coming inside or going outside, that will depend upon the size of the door. So what I meant, the number of molecules inside, that will depend upon the volume. Number of molecules inside, that will depend upon the volume. And what is the order of volume? So if the radius is r, the volume is 4 by 3 pi r cube. है ना? So the number of molecules inside the point, that will depend upon r cube. And how many molecules are going out or coming inside, that will depend upon the surface area, 4 pi r square. है ना? So this will depend upon surface area. Yes or no? Please check. Please check. Is it correct? Is it correct? Is it correct? यहां तक चेक कर लो, कुछ गलती तो नहीं की है? हाँ यार, रिप्लाई नहीं देते हो, बोर कर देते हो यार. ठीक है? Okay. I think it's fine for now. है ना? It's fine for now. Now check. For the point, I would like to write the density. So if I write the density of the point, how will I write the density? I will write the density as mass per unit volume. है ना? Now initially there were 10 molecules in the point. So how many molecules are there? 10. Every molecule has a mass m. So what is the total mass? 10 into m. And the volume of the point is v. So this is the initial density. Now what happened? New density. So let me call this as rho 1 and rho 2. New density. So initially there were 10 molecules. 3 molecules went out. 2 molecules came inside. So new number of molecules will be 9. So 9 into m by v. So this will become 9m by v. So I hope you can see that because of random molecular motion which happens in every liquid, every gas, every solid, है ना? In liquids and gases, the molecules are free to move. But in solids, the molecules are vibrating about their position. So what is happening? Because of random molecular motion, the molecules are moving in and out of the point. So with time, the density of the point is fluctuating. The density of the point is variable. So density has become a function of time. Also, let me do one thing. Let me write this percentage change. This percentage fluctuation, percentage change in density. So how will I write percentage change in density? Final density minus initial density, that is the change in density, upon initial density into 100. I think the value which you will get, that will be minus 10%. Yes or no? Kindly check. Clear or not? Kindly check. Clear or not? Kindly check. So Vineet says yes. What about Pooja, Satyam and Adarsh and Harnandan? हाँ, repeat sir, please density वाला. Why not? So beta ये देखो, initially there were 10 molecules in the point. So mass upon volume, that is density. So mass of every molecule m, mass of 10 molecules 10m. ठीक है? Now what happened? There were 10 molecules, 3 molecules went outside here in this figure, है ना? And 2 molecules came inside. So initial molecule is 10, 3 went out, new molecules came inside 2. So new number of molecules is 9. है ना? So what will be the new mass? 9 into m. Mass upon volume is the density. So this is how I write percentage change in density. So because of random molecular motion, the density is fluctuating with the time, and this fluctuation is actually a significant one. 10% is not an ignorable value. This is a significant value. So I think you should write a note over here. You should write a note over here. So what will be our rough note? Our rough note will be when the order of point is in Armstrong. I hope you remember when we started, we said the order of the point is Armstrong, 10 raised to power minus 10 meter. So you should write when the order of size of point is Armstrong. Size of point is Armstrong. ठीक है, that is 10 raised to power minus 10 meter. So I didn't mean that exactly 1 Armstrong. This can be 6 Armstrong, 7 Armstrong, or in fact 10 Armstrong also. That is 1 nanometer, but not larger than that. So when the order of size of point is 1 Armstrong, that is 10 raised to power minus 10 meters, the density, and in fact not only density, pressure, temperature, velocity, electric field, magnetic field, stress, strain, whatever is there, okay? So density or any other property shows local changes, shows significant local changes, kindly note it down please, significant local changes due to random thermal motion, that is molecular effects. Changes due to random thermal motion, that is molecular effects. Random thermal motion, that is molecular effects. ठीक है? Now let us do one thing. पहले लिख लेते हैं, है ना? पहले लिख लेते हैं, कंप्लीट कर लेते हैं. Random thermal motion, that is molecular effects. Molecular effects. Okay. Now check guys. Now initially I assumed that the point has an order of 1 Armstrong. Now let us do one thing. Let us consider that the point has a bigger size. Let me consider the point has a bigger size. And how much is the size? The size is 1 micrometer. So what we have? Again we have the same container. In the container we have the same substance, that is hydrogen. The molecules of hydrogen are moving in random direction, and we have a point over here which has coordinates x, y, z. But point is a 3D volume. So when you consider this point, the order of its radius or diameter is in 1 micrometer. Okay. Now, how many times is this size from the previous size? पिछले साइज के मुकाबले कितने टाइम्स बढ़ा दिया? सोचो, पिछले साइज के मुकाबले कितने साइज बढ़ा दिया? How many times is this from the previous size? So 1 micrometer is 10 raised to power minus 6 meter. Previous size of point was 1 Armstrong. That was 10 raised to power minus 10 meter. I think there is a ratio of 10,000 times. है ना? Micrometer is bigger than Armstrong by 10,000 times. So if you will consider the volume is proportional to radius cube. So if we increase the radius by 10,000 times, the volume will increase by 10 raised to power 12 times. And the surface area, that is r square, that will increase by 10 raised to power 8 times. है ना? So what I have done in my new explanation of point, I have taken the radius as 1 micrometer. This is bigger than previous explanation almost 10,000 times. Therefore, the surface area is bigger than by 10 raised to power 8 times and volume is bigger by 10 raised to power 12 times. समझ रहे हैं? तो बहुत बड़ा हो गया. विनीत बेटा चेक, आई हैव रिटन इन टर्म्स ऑफ टाइम्स. आई हैव रिटन इन टर्म्स ऑफ टाइम्स, है ना? इन टर्म्स ऑफ टाइम्स. कुछ गड़बड़ कर रहे हो? 10 रेज टू पावर -4 क्यों लिखा? 10 रेज टू पावर -4 क्यों लिखा? -3 क्यों लिखा? मतलब व्हाट वी आर टेलिंग फ्रॉम दैट? चेक करो. I have written I am making a comparison. I am making a comparison of this situation where the size of the point was 1 angstrom, and I am making and this situation where the size of point is 1 micrometer. So between the two situations, the difference of radius is 10,000 times. Area is 10 raised to power 8 times surface area of the point, and volume of the point is 10 raised to power 12 times. I hope you remember Avogadro law, huh? Avogadro law. So from ideal gas equation PV equal to nR bar T, we can find out how much is the number of molecules in a given volume, है ना? Now what happens is, if you consider this point which is 1 micrometer cube, है ना? How much? 1 micrometer cube. अरे भैया point will be 1 micrometer, 1 micrometer, 1 micrometer, है ना? And if you apply the Avogadro law, you will find out that in 1 micrometer cube, there are 3 crore molecules. How many molecules? 3 crore molecules of hydrogen at STP conditions. Of hydrogen at STP conditions. Again, just imagine 1 meter, 1 by 100 meter. So this will be 1 by 1000 meter, the distance between my nails. That is 1 by 1000 meter. We are talking of 1 by 1000 of that mm also. So that 1 micrometer, 1 micrometer by 1 micrometer by 1 micrometer. So that 1 micrometer cube has 3 crore molecules if it is a gas. Maybe 10 crore molecules if it is a liquid, and maybe 20 crore molecules if it is a solid. समझ रहे हैं आप? So even though this volume is extremely small, you can't see it, but it has very large number of molecules which is in the order of crores. Okay? So what we have? We have a new point, and in this new point, the number of molecules is like 3 crores. Okay? This is the number of molecules. Now check. So in this new point, the number of molecules is 3 crore. But again, the molecules are moving in random directions. Again, the molecules are moving in random directions, है ना? So when molecules are moving in random directions, some molecules will go out, some molecules will come inside. So let us say, for example, 10 lakh molecules come inside. How many molecules? 10 lakh molecules. That is 10 raised to power 5. And 9 lakh molecules go outside. So 10 lakh molecules is, I think, 10 raised to power 6, है ना? 10 raised to power 6, sorry. And 9 lakh molecules will be 9 into 10 raised to power 5. Now, may I ask one thing? आप देख रहे होंगे, when we have increased the size of the point. So 10 is the number of molecules in the point. Now the number of molecules is 3 crore. So 10 became 3 crore, but 2 became only 10 lakh, and 3 became 9 lakh. समझ रहे हैं आप? समझ रहे हैं? So there is an increase in number of molecules inside the point, but there is also an increase in number of molecules coming inside and going outside. But since the volume is R cube, the volume is increasing at a greater order. That's why this value became crore and this value became lakhs. समझ आया? Is my point clear to everyone? Is my point clear to everyone, or any doubt is there? Is my point clear to everyone, or any doubt is there? Initially there were 10 molecules, and the net molecules going outside was 1. Now the size of point has become larger. So this 10 has become 10 crore. It has become 1 crore. And this 1 has become 1 lakh. So why this has become crore and this has become lakh? because this depends upon the r cube value and this depends upon r square value. So obviously r cube is increasing at a greater order. ठीक है, तो आई होप ये क्लियर है और इसमें कोई डाउट नहीं है. सो ऐसा मत सोचना कि these values are taken randomly. I have chosen these values after some thought process. ठीक है, तो ये random values नहीं है. I have chosen these values after some thought process. ठीक है. Now let's see what happens. So for the same point, let us see what is happening to density. So for the same point, initially the number of molecules was 3 into 10 raised to power 7. So there will be some density. Now what is happening? 10 lakh molecules are coming inside. So 10 lakh molecules came inside. 9 lakh molecules went outside. So what is the new number of molecules? 3 crore plus 1 lakh. This is the new molecules. So initially the molecules were this much. Now the molecules are this much. So again I will find out the percentage change in density. Again I will find out the percentage change in density. So how will I write? I will write final density minus initial density upon initial density into 100. Obviously density depends upon number of molecules. So final number of molecules minus initial number of molecules into 100. Kindly calculate me what is this percentage change. Others clear hai? Vineet clear hai? Very good, very nice. Kindly check what is this percentage fluctuation. Kindly check what is this percentage fluctuation. You also calculate, I will also calculate. So this will become new number of molecules is 3 crore plus 1 lakh. Initial number of molecules is 3 crore and initial number of molecules is 3 crore into 100. So I think what I am getting is this will subtract. So I think what I will get is I will get 1 by 3. I will get 1 by 3. 1 by 3, right? I think this is what I am going to get. 0.33%. 0.33%. Right? एक बार check कर लो. Kindly check the calculation. I hope I am doing correct calculation. 1 by 300, 100 by 300. So 1 by 3, 0.33%. So guys, see what has happened. Just see what has happened. So when the point was 1 Armstrong, when the point was 1 Armstrong. So point size is 1 Armstrong. The radius of the point is 1 Armstrong. In that case, definitely density of the point is a function of time because some molecules came inside, some molecules went outside. So number of molecules is changing with the time. But when you will consider the percentage fluctuation in density, that is 10%. Arey bhaiya, mathematically very large value. But when the same point is of the order of 1 micrometer, so radius is 1 micrometer, then also the density is changing with the time because some molecules are coming inside and some molecules going outside. Now the percentage fluctuation in density is only 0.33%, which is a very small value. And in fact, mathematically we can neglect it because physically it is so small, it is not going to affect us. Physically 0.33% is so small, it is not going to affect us. In fact, in most of the fluid mechanics problem, if the change in density is less than 5%, we ignore that change in density. अगर change in density 5% से कम हो ना, तो हम उस change in density को ignore कर देते हैं. और आप लोगों को पता होगा, mark number less than 0.3 ऐसा कभी पढ़ा है ना? So that also I will relate to this point only, that the change in density is less than 5%. ठीक है? So this is a very small change in density and therefore it can be ignored. This thing can be ignored. So what we are getting, if we choose the size of the point wisely, if we are choosing the size of the point wisely, then we can ignore the local change of density because of molecular motion. We can ignore the molecular effects. So what do you mean by molecular effects? Microscopic effects, micro level study. So when you can ignore the molecular effects, you are doing macroscopic study. So this is what concept of continuum is. Choose the point size wisely so that you can ignore the effects of molecular motion. ठीक है? So this is first point of concept of continuum. So how many of you have got it? Sir, it means if we move towards 1 meter, नहीं विनीत ऐसा भी नहीं होता है बेटा. Actually there are two things. One is called as microscopic uncertainty and one is macroscopic uncertainty. अभी ये जो मैंने आपको बताया ना microscopic uncertainty है, हमारे सिलेबस में मैक्रोस्कोपिक अनसर्टेनिटी है नहीं, मगर वो जो वीडियो दिखाता हूं ना पावर ऑफ 10 वाली, आज भी हम देखेंगे, उसमें बता दूंगा, हल्का सा आइडिया दे दूंगा मैक्रोस्कोपिक अनसर्टेनिटी होती क्या है. ठीक है, तो क्या होगा अगर आप पॉइंट को बड़े साइज का ले लोगे ना, तो डेंसिटी फिर से डिसकंटिन्यूअस फंक्शन ऑफ पोजीशन बन जाएगा, जो कि हमारे लिए यूजफुल नहीं है. अभी थोड़ा सा आगे बढ़ते हैं तो बताता हूं. ठीक है, so guys, this is the first point. Actually Vineet was asking something, so no need to get confused. I will discuss that also within a few minutes. So for now, this is the first point of concept of continuum. When you are writing Eulerian approach, you are writing property value at a point. Then you choose the size of a point in a wise manner so that you need not consider the molecular effects. And this type of study is called as macroscopic approach. ठीक है, तो ये तो था first point. Now I think it would be better if we summarize a note of it, है ना? It would be better if we summarize a note of it. So you can write hence by taking the point, by taking the size of point. Hi AM, a very good afternoon. AM, हम वही यूलेरियन लैग्रेंजियन अप्रोच की बात कर रहे हैं जिसमें कॉन्सेप्ट ऑफ कॉन्टिन्यूम कवर कर रहे हैं, और जो हमारा नेक्स्ट क्लास का टॉपिक रहेगा वो व्हाट इज फ्लूइड रहेगा. व्हाट इज फ्लूइड होने के बाद मैं प्रॉपर्टीज चालू करूंगा. सो हेंस बाय टेकिंग द साइज ऑफ पॉइंट ऑफ द ऑर्डर ऑफ 1 micrometer, of the order of 1 micrometer, the random fluctuations, or you can write local change also, the random fluctuations bracket local change, random fluctuations bracket local change, random fluctuations bracket local changes of properties due to random thermal motion of molecules, motion of molecules can be ignored. Random thermal motion of molecules can be ignored. Hence properties can be defined. Without considering molecular effects. Properties can be defined without considering molecular level activities. This is also called as macroscopic study. Without considering molecular level activities, this is also called as macroscopic study. ठीक है? I think this will be useful for mechanical people if they are studying thermodynamics, है ना? Whenever they are studying thermodynamics, so now they know what is macroscopic study. In fact, every engineer is using this idea. ठीक है? When we write stress at a point in strength of materials, actually we are talking of this idea. our point stress at a point. So point size is of 1 micrometer and we do not consider the molecular effects. So whatever you are doing, whether you are doing heat transfer, geotech, strength of materials, fluid mechanics or solid mechanics, this thing is over there. Concept of continuum is over there. Okay? So this was the first point of concept of continuum. Now second point of concept of continuum. Okay? Second point of concept of continuum. So let's see what the second point is. So now instead of taking a gas, I will take a solid body, say for example iron. Say for example iron. And if you talk of iron, so again the atom of iron is of same order, 0.7 Armstrong. 0.7 Armstrong. So what we have? We have iron atom. And there will be void space, iron atom, void space, iron atom, hai na? So like this, we will see the iron atoms. These are iron atoms which are arranged in their lattice points. When we talk of solid, the atoms are fixed at their positions, not completely fixed, but they are vibrating at these positions, hai na? So this is how the atom looks like. Now guys, check. Let me do one thing. Let me consider that the size of a point is of the same order. So what is the size of a point? What is the size of point? 1 Armstrong. It is of the same order. Same order means the atom and the void space. Obviously, this figure is a little exaggerated क्योंकि एक्चुअल में इतना स्पेसिंग भी नहीं होता है. अगर आपको आयरन का अरेंजमेंट दिखाएं, सो आई होप यू हैव स्टडीड मटेरियल साइंस. हाउ मेनी ऑफ यू हैव सीन इन मटेरियल साइंस? लेट मी शो यू आयरन. How many of you have seen material science? How many of you have done material science? What is the lattice arrangement of iron? What is the lattice arrangement of iron? Anyone? नहीं याद है? याद नहीं है क्या? बताओ यार, बता दो. I think there are different forms of iron. They can exist in FCC also and BCC also, है ना? So obviously the void space is not too much. मैंने मतलब थोड़ा सा exaggerate करके बताया है. But for me ना, explanation will become easy. That's why I have exaggerated a little. ठीक है? So depending upon alpha, beta and gamma, so iron can exist in FCC and BCC form, right? So what we have, let me suppose this direction is x direction. What is this direction? X direction. And what I want to do, I want to make a graph of density versus x. What I want to do, I want to make a graph of density versus x. So what I will do, at every point, I will find the value of density and put it on the graph. So obviously this will become the first point. So every point is of the same order, 1 Armstrong. So at the first point, there is an atom. So there will be mass, there will be value of density. So this is the value of density at the first point. At the second point, there is a void space. Void space means no atom, no mass, no density. So at the second point, the value of density will be 0. Then the third point. So at the third point, there will be again an atom. So there will be again a density, है ना? Then at the fourth point, there is void space. So again 0 density. So I think when I'm making a graph of density versus x, this is how the graph will look like. Kindly check if I'm doing it correctly or not. This is how the graph of density versus x will look like. Kindly check if this is correct or not. Correct or not? Kindly check. Correct or not? And tell me whether this is a continuous function, whether this is a continuous graph. Whether this is a continuous graph. Whether this is a continuous graph. I don't think so. I don't feel this is a continuous graph. So it definitely appears that density is a discontinuous function of position coordinate. Density, pressure, temperature, velocity, acceleration is now discontinuous function of space coordinates. And if you have discontinuous function, then you cannot use calculus to solve those discontinuous functions. You will not have any method to solve those discontinuous functions. Correct or not? Correct or not? We won't be able to solve those discontinuous functions. So what we want? We want continuous functions. I want that when density is a function of position, it should be a continuous function of position. It should not be a discontinuous function. Otherwise, I will not be able to solve my calculus. So what I will do? I will again increase the size of the point. I will again increase the size of the point. So what you will do? Again, if you take a point of 1 micrometer, again if we will take a point of 1 micrometer. So these are the atoms, which are like, these are the atoms which are like 1 Armstrong, and obviously in between the atoms there are void spaces, right? So when I will take a bigger point which is 1 micrometer, so this is my first point, this is my second point, this is my third point. So actually every point has sufficient number of atoms. How many atoms? Crores of atoms. Every point has sufficient number of atoms that density will become continuous function of position. So this is also concept of continuum. If you choose the size of your point very small, so small that the point is of the order of an atom or molecule, your properties will become discontinuous function of space, because there will be a point with mass, there will be a void space. There will be a point with mass, there will be a void space. But if your point is of the bigger order, such that every point has crores of molecules, we will observe that density and other properties will become continuous function of position. Right? Is that clear? Is that correct? All of you kindly check. All of you kindly check. This is the second point of concept of continuum. This is the second point of concept of continuum. सत्यम बेटा समझ आ गया? Kindly check सत्यम. वैसा ही है जैसा मैंने क्लास में एक्सप्लेन किया था, वैसा ही है जैसा मैंने क्लास में एक्सप्लेन किया था. And if this is correct, then we can make a note. We can make a note. So again, concept of continuum means choosing the size of point in such an order. Choosing the size of point. So it says concept of continuum. Continuum means choosing the point in such an order that the properties become continuous function of space. Continuum, continuous. यहाँ से बना continuum. ठीक है? Choosing the size of a point. Choosing the size of a point in such a way that every point has sufficient number of atoms. Every point. So point, what do you mean by point? Something of the order of 1 micrometer. Every point has sufficient number of atoms / molecules. Sufficient number of atoms / molecules. So what is that number? If you want to write in bracket, you can write 10 raised to power 7, 1 crore. Sufficient number of atoms / molecules that properties are continuous function of space. That properties are continuous function of space. Properties are continuous function of space coordinates. Continuous functions of space coordinates. This is entire your concept of continuum. Entire concept of continuum. ठीक है? Choosing the point wisely so that even if property is a function of time, it is not a result of molecular effects. Molecular effects can be ignored, and the property is continuous function of space and time. So this is your concept of continuum. Clear है? Clear है? NPTEL की वेबसाइट पे एक बहुत अच्छा डेफिनेशन दे रखा है, मगर मुझे लगता है कि अगर आपने ये पॉइंट्स लिखे हैं, सो दिस पॉइंट हैज बेटर एक्सप्लेनेशन एज कंपेयर टू दी NPTEL. तो अगर चाहो तो सोम साहब का जो NPTEL PDF है वो डाउनलोड भी कर सकते हो, वहां से भी डेफिनेशन लिख सकते हो, मगर मुझे लगता है कि ये अपने आप में सेल्फ सफिशिएंट पॉइंट्स हैं. So anyone having a doubt till now? Now guys, what will happen? Sometimes in the books, not in all books, but sometimes in good books, like PK Nag also, a figure is there. Okay? In PK Nag, some sort of figure is given to us. What is the figure? On the vertical axis, there is a property, density. Say for example, density at the point. And on the horizontal axis, we have the volume of the point. Okay? So what they are saying, if the volume of the point is very small, then density at the point will fluctuate with the time. So they have shown a figure like this. They have shown some sort of figure like this. They have shown some sort of figure like this. Okay. So what they are trying to say, if we will choose a point whose radius has an order of 1 micrometer, so volume will become 1 micrometer cube, then the fluctuation of density because of time will be negligible. Actually, this represents fluctuation because of molecular effects. And this is called as microscopic uncertainty. Microscopic uncertainty means fluctuation of property value because of molecular effects. So we are not certain what is the exact value of property. Okay? Microscopic uncertainty. Now, if your point has sufficient volume 1 micrometer cube, so the property fluctuations because of molecular effects can be ignored. So there is no molecular effect, so density will remain constant. But we will observe that again when the point is very large in size, some sort of fluctuation is observed. That is called as macroscopic uncertainty. इसको हम बोलते हैं मैक्रोस्कोपिक अनसर्टेनिटी बोलते हैं. अभी बताता हूं कैसे, ठीक है. बट आई विल नॉट एक्सप्लेन इट टू डीपली. इवन आई एम नॉट श्योर अबाउट इट कि इसकी एग्जैक्ट एक्सप्लेनेशन क्या है, बट हल्का सा हिंट मिल जाएगा फ्रॉम द वीडियो दैट वी वॉच ऑलवेज. पावर ऑफ 10. मैक्रोस्कोपिक अनसर्टेनिटी. ओके, सो ठीक है, फिर अपना वीडियो देखते हैं. वन वीडियो वी शैल वॉच and then I will try to explain it. So have a look at this video. Just one moment please. So I hope this is clear and no doubt is there. So actually concept of continuum is already over. Just one more thing we will write, that is Knudsen number. और फिर उसके बाद एक आध प्रैक्टिस क्वेश्चन कर लेते हैं फ्रॉम लास्ट क्लास, है ना, बिकॉज टाइम इज स्टिल देयर. सो दिस इज योर पावर ऑफ 10. So everyone kindly have a look at this video. You can find this video on YouTube. There are multiple versions of this video now, and this video is actually an old one. So because it's old one, it came out in 1970s. It was made by some PhD scholars of IBM, and it has some incorrect data also. So I will show you an example. But you can watch the new versions, HD versions. So HD versions are very fascinating also if you will look at them. But मैं यही दिखा रहा हूँ, old video ही दिखा रहा हूँ, because the speed of the video is comparatively slow and it is easy to talk side by side. That's why. ठीक है? So what you will see a frame, you will see a square, and the size of the frame will be written, that is 1 meter by 1 meter. So initially the camera is focusing on that frame from some distance, and as the time will pass by, the camera will move away from the frame. So with every 10 seconds, one side of the frame will get multiplied by 10. So if something is 1 meter initially, then it will become 10 meters. If something is 10 meter initially, then it will become 100 meter. So right now you are looking at a frame 1 meter by 1 meter. ठीक है? Now just for one moment please, ठीक है? Just for one moment, have a look at this. Let me do one thing. Let me take a clipping of this and let me copy paste it over your slide. ठीक है? तो ये देखो, I have copy pasted. So this is 1 meter by 1 meter frame, and in this 1 meter by 1 meter frame, I will take a point. So this is the point. Obviously you can see what is the size of the point. So most probably the size of this point is in the order of 1 mm. Right now the point that I have taken is of the order of 1 mm. So at this point there is some mass, there is some density. At this point also there is some mass, there is some density, there is some mass, there is some density, there is some mass, there is some density. So it appears as if density is a continuous function of space. So even instead of 1 micrometer, if I take 1 mm, then also the density is a continuous function of space. ठीक है ना? चलो फिर अब आगे बढ़ते हैं. Let's see the video and the camera will start running away. अच्छा योगेश बेटा, बहुत सालों के बाद HPCL का जो एग्जाम हो रहा है वो अलग से हो रहा है बेटे. तो क्या है कि एक तो HPCL के एग्जाम में ना कंपैरेटिवली क्वेश्चंस का लेवल इजी रहता था पहले. तो गेट एग्जाम के मुकाबले काफी इजी क्वेश्चंस आते हैं. और फिर इस बारी कोविड का भी चक्कर पड़ गया तो बहुत सारे पुराने बच्चे भी पेंडिंग है ना. तो थोड़ा सा ना मेरे लिए कट ऑफ का अंदाजा लगाना डिफिकल्ट होगा बेटा कि क्या कट ऑफ है. मतलब आप लगा लो कि जब मैं कॉलेज में था 2010-11 में तब HPCL का एग्जाम होता था. उसके बाद से HPCL ने गेट के थ्रू लेना शुरू कर दिया था. तो मुश्किल है बेटा कहना. 2011 से गेट से ही ले रहा था HPCL और सिलेबस गेट का ही है मगर क्वेश्चन आएंगे इजी. So guys, you can see, I hope you can observe, it has become 10 meter by 10 meter, है ना? The frame has become 10 meter by 10 meter. Again what will happen? You will take this frame. Again what will happen? You will take this frame. You will copy the frame on the slide. You will take one point on the frame. So now one point will be like 10 centimeter. So at every point there is some mass, there is some density. So density is a continuous function of position. है ना? I think this is what we are looking at. So now, so basically I'm increasing the size of point one by one. So now it will become 100 meter. आप लोग कहते हो I walked 1 kilometer today. अरे it was not 1 kilometer. It was only 300 meter. Just see how much 100 meter is. Within 100 meter by 100 meter, you can see a 6-lane road. You can see a park and you can see a dockyard also. So even that is very big. Okay. Now it will become 1 kilometer by 1 kilometer. Then it will become 10 kilometer by 10 kilometer. So 10 kilometer by 10 kilometer, you can see a very big city in that metropolitan kind of city. So 10 kilometer by 10 kilometer means 1/4 of Bangalore, and Bangalore is humongous. So this is 10 kilometer by 10 kilometer, 100 kilometer by 100 kilometer, a medium size state. And matlab a state sorry. And now we have 10,000 kilometer by 10,000 kilometer. So this data is actually wrong because I hope you know that diameter of earth is like 12,000 kilometer. So slightly mistake is there, है ना? Now Vineet will get his answer. Vineet, beta check, kindly check. So Vineet asked, sir, this means if we take a very large size of point, even if we take a few meters or something, the approach will be correct only, है ना? ऐसा कुछ बोला था. अब ये देखो. Right now, you might say, sir, this is my first point. This is my first point. So in this photo, every point has the order of how much? A few kilometers, है ना? Every point has the order of few kilometers. At this point, there is some land mass. So this land mass will be sandy. So it will have some density. At the other point, there is some water mass. See, है ना? So this is the density of water. This is the density of water. This is the density of silicon dioxide, sand. And here the sand is tough. So at all these points there is some mass. At all these points there is some density. So you might feel that density is continuous value, but actually it is not continuous value. Because here you have the density of water. Here you have the density of soft sand, and here you have the density of hard sand. So again the density is becoming a discontinuous value. समझ आया? समझ आया? So it is some range only. It is a very small range, maybe from 1 micrometer to up to 0.1 mm. Maybe from 1 micrometer to up to 0.1 mm or 1 mm, where the concept of continuum is applicable. Because if the size of the point will be bigger, then again it will become discontinuous function. ठीक है? I hope समझ आ गया है, सभी को समझ आ गया. Vineet got it because Vineet has discussed this with me earlier also, but I hope others have also got it. Now check guys, now check. Now what will happen? We will see Earth. Earth will also become a point, है ना? Now the point is of the order of Earth. भैया for भगवान जी के लिए तो क्या कहते हैं, अर्थ एक पॉइंट ही है ना? For him, in him or her, Earth is a point only. Now if you will take one point on Earth, there is some mass, so there is some density. But if you will take the neighboring point, there is no mass, so there is zero density, है ना? So check for yourself. So what we have again. So this is my first point. This is my first point. So there is some mass, there is some density. This is the next point. There is no mass, there is no density. So discontinuous function. But you know what will happen? Just have a look. So now we will be able to see the other planets also. We will be able to see the sun also. We will be able to see the solar system. And ultimately a time will come when you will be able to see your galaxy also. ठीक है? Just see what is going to happen. So what we are doing in this video, we are increasing the size of the point. We are increasing the order of the point one by one. है ना? This is what we are doing. Just imagine, just check what will happen. Now the sun has become a point. The order of the point is the order of sun. Order of the point is the order of sun. Our universe is extremely big. So yes, sun can be a point. Yes, sun can be a point. When you are studying your solar system, sun is nothing but a point. So थोड़ा सा ज़्यादा वीडियो हो गया ना, लंबा वीडियो हो गया. Let me move a little ahead. Now you will be able to see the stars in our galaxy. Now you will be able to see the stars in our galaxy. Just hold on. Now let us take our photo again. ठीक है? So right now my density is discontinuous. So what we have, every point is of the order of a star. Every point is of the order of a star. So this is your first point. We have a star over here. So we have some density over here. But if you take the next point, there is nothing. So there is no density. If you take the next point, then again there is a star. So there is some density. You take the next point, again there is a void. है ना? So right now, density is a discontinuous function of position. But if you will go to the next order, when you are able to see the galaxy, check what will happen. Is the density continuous function of position again? Is the density continuous function of position again? Yes or no? Am I right? है ना? So at this point there is some density, at this point there is some density, at this point there is some density. So density has become a continuous function of position again. So actually what happens, it's not like कि density is always continuous. It is not like this. It is not like properties are always continuous. Okay? So for a given range of the size of point, the density will be continuous function of x. Then for the next range, it will be discontinuous. Then for the next range, it will be continuous. समझ रहे हैं आप? तो पहले discontinuous होता है, फिर से continuous बनता है, फिर discontinuous होता है, फिर से continuous बनता है. So the thing is, we don't deal with universe, solar system and stuff, so we need not worry about it. But those people who understand the flow of galaxy, the motion of galaxy, the deformation of galaxy, then they have to deal with it. समझ रहे हैं आप? So it depends upon type of studies. In our type of studies, the point is 1 micrometer for which the concept of continuum is applicable. ठीक है? That much is sufficient. Now one thing is there, there is a term called as Knudsen number. Which term? Knudsen number. Knudsen number. Okay? Obviously, you might be aware that numbers mean dimensionless number, है ना? So we denote it by Kn. Now this Knudsen number actually helps us to tell whether the concept of continuum is applicable or not. Whether if there is a system and you define the size of the point wisely, then the properties will be function of position or not. Microscopic effects can be ignored or not. Okay? What is Knudsen number? Knudsen number tells you that if there is a system and you choose your size of point wisely, then can you make the properties continuous function of position? Can you ignore the molecular effects? This is what Knudsen number is going to tell us. And what is Knudsen number equal to? Knudsen number is equal to the characteristic length. Knudsen number is equal to mean free path divided by characteristic length of the system. This is mean free path of molecules. This is mean free path of molecules. Mean free path of molecules. Free path of molecules. And this is characteristic length of the system. Okay? Actually, the upper term is the distance traveled by a molecule to collide with other molecule. Okay. So upper term kind of tells us molecule to molecule collision. What it tells us? Molecule to molecule collision. And the bottom one tells us molecule to solid boundary collision. Okay. So this ratio is related to the frequency of molecule to molecule collision and molecule to solid boundary collision to the boundary of the system. Okay? So what it says, if the Knudsen number of a system is less than 0.01, we can use concept of continuum. We can identify the size of point wisely and make properties continuous function of position and ignore microscopic effect. But if this value is greater than 0.001, then you cannot choose the point in any way to make properties continuous function of position and time, and molecular effects have to be considered. ठीक है, मैं एक बार हिंदी में बोल देता हूँ, इंग्लिश में मैं थोड़ा सा गड़बड़ कर गया. अगर नट्सन नंबर की वैल्यू 0.01 से कम हो तो कॉन्सेप्ट ऑफ कॉन्टिन्यूम एप्लीकेबल होता है. आप अपने पॉइंट साइज को चूज कर सकते हो ताकि प्रॉपर्टीज कंटिन्यूअस फंक्शन ऑफ पोजीशन बने और मॉलिक्यूलर इफेक्ट्स को कंसिडर ना करना पड़े. बट अगर नट्सन नंबर ग्रेटर देन 0.01 है तो आप किसी भी वे में पॉइंट साइज डिसाइड नहीं कर सकते ताकि प्रॉपर्टीज कंटिन्यूअस फंक्शन बने और मॉलिक्यूलर इफेक्ट्स ना कंसिडर करने पड़े. इन केसेस में चाहे कुछ भी पॉइंट साइज हो, प्रॉपर्टीज विल बी डिसकंटिन्यूअस एंड मॉलिक्यूलर इफेक्ट्स हैव टू बी कंसिडर्ड. ठीक है, आई होप नाउ आई हैव सेड करेक्टली. ठीक है, कॉन्सेप्ट ऑफ कॉन्टिन्यूम नॉट एप्लीकेबल. कॉन्सेप्ट ऑफ कॉन्टिन्यूम नॉट एप्लीकेबल. ओके, so I hope this is clear. This is clear. I'm not going deep into this because chances of getting question are not there. But since we are dealing with Eulerian approach, we have to write the value of property at a point. So we should know what a point size must be. ठीक है? अच्छा, एक आज के लिए काम करते हैं, इतना sufficient करते हैं. ठीक है? Next class में क्या करेंगे? In the next class, initially we will try to revise local and convective acceleration. Slightly local and convective acceleration के numericals revise करेंगे. वैसे मैंने सोचा था कि आज ही करेंगे, बट कुछ बार बार इंपॉर्टेंट मैसेज आ रहा है और घर से आ रहा है तो मुझे लग रहा है कि कहीं ज्यादा इंपॉर्टेंट ना हो. उनका कॉल भी आ रहा है बार बार. ठीक है, आजकल वैसे ही थोड़ी आपको पता ही है क्या सीन चल रहा है ना. सो नेक्स्ट टाइम कंटिन्यू करेंगे and we will discuss what is fluid. So what we have done till now, we have seen the prerequisites, we have seen Eulerian Lagrangian approach, we have seen concept of continuum, what is a point. We should also know what is fluid. So our next topic will be what is fluid. Once we are done with what is fluid, we will start discussing the properties of fluid. So go slow क्योंकि हम धीरे धीरे चल रहे हैं. आप FM को यहां से कंप्लीट कर सकते हैं और अपना बाकी जो टाइम है आप अपने सब्जेक्ट्स पे फोकस कर सकते हैं। डेली का 1-1.5 घंटा मेरे साथ पढ़ो, अगले दिन उस 1-1.5 घंटे को रिवाइज करो एंड देन नेक्स्ट डे कम टू द क्लास बैक। ठीक है, दिस इज हाउ यू कैन डू। विनीत और अपने फ्रेंड्स को भी बता सकते हो। ठीक है, डेली 1-1.5 घंटे की क्लास होती है, सो इट्स जनरली 1.5 आवर। आज मैं थोड़ा जल्दी छोड़ रहा हूं, सो जनरली इट्स 1.5 आवर। So one day you can study with me, next day you can revise, then again you can study and again you can revise. And what will happen? This will take the burden from you for studying fluid mechanics. तो आप fluid mechanics मेरे साथ पढ़ सकते हो और बाकी सब्जेक्ट खुद से कर सकते हो। ठीक है, तो चलो ठीक है, फिर चलते हैं अभी। I will see you next time. Thank you. Bye bye.